Now I want to look and see what visually happens on the argand diagram here if I get complex numbers or real numbers and add the same complex number over and over. Or maybe I want to get different numbers and multiply by the same complex number. It's just to see visually what's going to happen. So let's say we pick the number 2 plus 4i. That's it on the argand diagram. What would happen if I added this number here, 1 plus 3i? I get 3 plus 7i. And if I wanted to plot that, 3 plus 7i is there. Let's say I picked a different original, complex number here. Let's say I picked minus 1 plus 2i. I'm sorry, there. And what happens if I add the same complex number again, 1 plus 3i, same as before? I'd get 0 plus 5i, which is here. And let's say I got a third one, minus 3 minus 4i, which is there. And I add the same complex number as before, 1 plus 3i, always 1 plus 3i, I'm consistently adding to different complex numbers. I end up at minus 2 minus I, which is there. And if I look over and over, here to here is the same translation as here to here, which is the same translation as here to here. So I just happen to be having translations. So if I want to move a point the same way as this one, I just add the same complex number as I did up here. Same distance, same direction, and that's what adding the same complex number over and over again to different complex numbers or real numbers will do for me. We could look visually at what would happen if I multiplied by a number. So let's say I picked a complex number, let's say 2 plus I. I'll go to a different sheet. And if I plot 2 plus 1i, it's there. What would happen if I multiplied that by the number 2? I'd end up with 4 plus 2i. And let's say I picked another complex number, minus 3 plus 2i is here. And I multiplied that one by 2, so I'm consistently multiplying by just a whole number, this time a whole plus number. I'd end up with minus 6 plus 4i. Which is there. And let's say I pick the number minus 1 minus 2i, which is here. And I multiplied that by 2. I'd end up with minus 2 minus 4i. Which is there. What's consistently happening? The distance from the origin is getting further and further away. Well, it's actually doubling in distance every time. If I look, distance from there to there is doubled because I multiplied by 2. The distance from here to here is doubled because I multiplied by 2. So if you multiply by the same whole number greater than 1, if I multiply by 1, it's going to just be in the same place. And if I multiply by 2, it's going to double its distance from the origin. Multiply by 3, it's going to treble its distance from the origin, and so on. So that's all I did. I got 3 different numbers and multiplied them by the same number, and that's what I got here. A question for you. You can press pause and work this out for yourself, draw it in your diagram. What happens if you multiply these 3 numbers, or pick your own ones if you want, by a fraction? So let's say I multiplied them all by a half. Work it out for yourself. maybe pick a few numbers, press pause on the video and check it out for yourself if you don't already know what would happen if you multiplied maybe by the same fraction. So what would happen is that if you multiply by a half, you'd get closer to the origin. You'd half your distance to the origin. Let's look at what else could happen here. Perhaps if we chose something else to do. What happens if we decided we wanted to multiply by I? So let's say I picked the number 2 plus I. What would happen if I multiplied that by I? Well, if I multiplied it by I, I'd end up with 2I plus an I squared, which I work out, I squared, I straight away change to minus 1. So minus 1 plus 2I. So that's a minus 1 plus 2I. I pick a different number, minus 3 plus 2I. It's minus 3 plus 2I. I might go in a different colour here. Minus 3 plus 2I is here. Okay, and if I multiplied minus 3 plus 2I by I, I'd end up with this, I squared, I should change to minus 1, and I'd end up with minus 2 minus 3I, which is here. And maybe I'll go for a different colour again this time, and I pick a different number, so minus I minus 1 minus 2I is there. And if I multiply by I, I'd end up with this. I squared, I straight away change to minus 1, I end up with 2 minus I. So, looking here, mightn't be as easy or straightforward to see. What happened was the point rotated 90 degrees from its original point. Rotated this direction 90 degrees. If we look at this one, and we compare it to the origin, again, it's rotated 90 degrees from its original point. And same here, if we look at this one, I'll do it in green this time. If we go to the origin, and out the other side, to its new point or moved point, it has moved 90 degrees in all of them rotating this direction. That's what happens if you multiply by a number by I. Question for you then, that you can pause. If you don't know the answer, you can pause the video and check it out for yourself, is what would happen if you pick 3 different complex numbers or real numbers and multiply them by minus I. The answer is you'd rotate 90 degrees, but it would be in this direction. Okay, so multiplying by minus I would go 90 degrees rotation, but in the opposite direction as if you multiplied by I. All of this could fully make sense for you if you have a good knowledge and understanding of these rules that we looked at in one of the previous videos. And you can always mess around with different numbers and see what happens if you add the same number, multiply by the same number, and so on, and see visually what happens.